Assalamualaikum warahmatullahi wabarakatuh. My name is Abdul Aziz. I'm from Group 4. Today we will present about nanofiltration. In this group we have 3 members. Number 1 is me, Abdul Aziz. Second Amirul, and third Farizwan. Subject membrane technologies. Code subject is KEJ 4602. Nanofiltration is one of a group of similar membrane processes include reverse osmosis, ultrafiltration, and microfiltration. Used most often with low total use of solid water and fresh groundwater, and removal of disinfection by product processes. For example, we can see this system can use in landfill. The main objectives of this review is to illustrate the main applications of nanofiltration process in water reuse, wastewater treatment as tertiary treatment, water softening, and desalination fields. How nanofiltration work? Characteristics of nanofiltration fall between ultrafiltration and reverse osmosis and function by both pore size flow and the solution diffusion mechanisms. Membrane charges play an important role in membrane function, and often nanofiltration membrane as have surface negative charges. The main job of nanofiltration is the selective removal of ion and organic substance, and it is used in some specified seawater desalination application. So that's why we can see this system used in landfill, also seawater treatment, something like that. In nanofiltration membrane, we have three process principles. Number 1 is membrane filtration, best method that use nanometers sizes through pore that pass through the membrane. Have pore size of 1 to 10 nanometers. Membrane used are prominently created from polymer thin films. Since nanofiltration has some unique physiochemical properties that lend themselves for the treatment of landfill leachate, for instance, carbon nanotube membrane can remove almost all kinds of water contaminant, include turbidity, oil, bacteria, viruses, and organic contaminant in the landfill leachate while treating. Also, nanotechnology can able to tackle the removal of impurities, sediment, chemical effluent, charged particles, bacteria, and other pathogens at faster rate, which causes contamination in the landfill leachate.
I am Amirul. I would like to talk about application of nanofiltration, which is used to treat the raw leachate using nanomembrane filter, which helps in softening of wastewater. For instance, it removes polyvalent cation and involved in disinfection. To remove the infecting byproduct precursors such as natural organic matter and synthetic organic matter, to satisfy regulatory norms for leachate discharge into the environment. Next, I would like to talk about characteristics. The major organic and inorganic components are BOD, COD, PS, TXS, TDS, calcium ion, and sodium ion were analyzed in the laboratory. The total hardness calcium ion was determined by titration with 0.02 N EDTA with aerochrome black tea as indicator. The sodium ion concentration and presence was determined using flame photometer. The chemical oxygen demand was determined by titration against 0.1 N ferrous ammonium sulfate, where sulfuric acid with reagents standard potassium dichromate, 1 pinch mercurous sulfate, and silver sulfate were added to the sample before titration. Then I would like to talk about method. Required amount of leachate is taken and poured into the experimental setup using measuring jar. The leachate was fed into the alumina bed thickness of 2 cm and kept it for about 48 hours to absorb the contaminants present in the leachate. After 48 hours, it is clearly absorbed that the color leachate changed from black to brown color. It shows that activated alumina absorbed the oxide particles present in the leachate. After that, the leachates pass through the carbon filter, the activated carbon at the top with the thickness of 2 cm. Below the carbon layer filter consists of sand layer of thickness of 8 cm, which consists of sand particles, which pass through 4.75 mm and retains in 2.36 mm sieve. Next to the sand layer, the filter consists of layer of small pebbles of thickness 6 cm. At the bottom of the filter, it has large pebble layer of about 5 cm thickness. This carbon filter removes contaminants and impurities present in the leachate fed from the alumina bed using chemical absorption. The leachate is then allowed to pass through the nanofiltration system. This system consists of sponge filter, a discharge pump, and nanofilter membrane. The filtered water from the carbon filter is passed through the sponge filter. The sponge filter has the pore size of 5 microns. It removes the particles having the size more than 5 microns. After it is filled, it is fed to the nanofilter housing with the help of suction pump, which has the discharge capacity of 1.2 liters per minute. After pass through the nanofiltration, it is collected and tested for analyzing the results.
Membrane configuration. Membrane configuration has four types, which is plate and frame, tabular, spiral wound, and hollow fiber. First one is plate and frame. It consists of two end plate, flat sheet membrane, and a spacer. Plate and frame membrane system utilize membrane laid on top of a plate-like structure, which in turn is held together by a frame-like support. Flat sheet membranes are bolted together with a frame around the perimeter, similar to a heat exchanger or filter press. There are two types of plate and frame membrane configuration: dead end and cross flow. In dead end plate and frame system, the feed solution flow perpendicular into the membrane, while cross flow systems are made so that the flow is tangential to the membrane wall. Because the flow is perpendicular to the membrane, dead end plate and frame membrane separation work through a process called cake filtration. For cross-flow plate and frame membrane system, falling of the membrane is significantly less because the flow is tangential and does not require use of cake filtration system. Second membrane configuration is tabular membrane configuration. Tabular membrane modules are tube-like structure with porous walls. Tabular modules work through tangential crossflow and are generally used to process difficult feed streams such as those with high dissolved solid, high suspended solid, and oil or grease. The membrane is often on the inside of a tube. The feed solution is pumped through the tube. Tabular modules consist of a minimum of two tubes: inner tube, which is called the membrane tube, and the outer tube, which is the shell. The feed stream goes across the length of the membrane tube and is filtered out into the outer shell while concentrate collect at the opposite end of the membrane tube. The third membrane configuration is spiral wound. Spiral wound element consists of membrane, feed spacer, permeate spacer, and a permeate tube. A flat sheet membrane wrapped around a perforated permeate collection tube. The feed flow on the other side of the membrane and spiral in toward the center of collection tube. Feed travel through the flow channel tangentially across the length of the element. Filtrate smaller than the molecular weight cut off will then pass across the membrane surface into the permeate spacer, where it is carried down the permeate spacer toward the permeate tube. The remainder of the feed then becomes concentrated at the end of the element body. The last one is hollow fiber. Hollow fiber filtration utilizes thousands of long porous filaments ranging from 1 to 3.5 mm wide. They are potted in place in a PVC shell. Each filament is very narrow in diameter and flexible. Hollow fiber can find use in all types of filtration. Hollow fiber membrane configuration is a bundle of hollow fiber in a pressure vessel. A shell feed configuration where the feed pass along the outside of the fiber and exit the fiber end. Both side feed configuration where the feed is circulated through the fiber. Hollow fiber filtration work on the same principle as tubular and capillary configuration, but utilize a small tube diameter which allow for flexibility. There are a few advantages and limitations when using nanofiltration membrane. The first advantage is it requires lower operating pressure. The second one is it has the capability to remove recalcitrant organic matter from landfill leachate. The third one, it has higher flux than RO membrane. The fourth one is it has better retention than ultrafiltration membrane. The fifth one is it has high rejection of polyvalent ion and organic matter with a molecular weight between 200 to 1000 Da. The last one is it requires low operating and maintenance costs. As for the limitation, it requires a higher energy consumption. The second one, the membrane is a little bit more expensive than reverse osmosis membrane. And the last one, pretreatment is needed because leachate is a heavily polluted water. So, the conclusion is nanofiltration can be effective in treating landfill leachate, although leachate characteristics must be considered. Nanomembrane treatment is brought in the test as follows. Nanofiltration membrane mainly involve removal of COD, BOD, and polyvalent ion in leachate produce efficient removal of hard and inorganic contaminant insoluble. It can be assumed that treated water can be used for watering toilet, watering grass, and other purpose, etc. Therefore, the process is friendly without use of unwanted chemical, durable, low electricity, with the help of zero operation and less maintenance costs.
For this group assignment, my group and I work together to complete it. We do meeting regularly to find what we need and ask opinion about what we should put and what we should not put. We always ask each other, is this suitable for our group assignment or not? And I would like to thank my group members Abdul Aziz bin Marhakim and Muhammad Farizwan bin Fairul. After all, they give full commitment to complete this assignment. Overall, I'm very satisfied with our work. Thank you very much, everyone.
I would like to thank all my team members, Amir Ashraf and Farizwan for their good cooperation in carrying out this task. We do together to find information related to the topic. Besides that, I am very satisfied doing this group work together. Hopefully we can do this after this.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Farizwan bin Muhammad Fairul. I'm from Group 4. My group member is Amirul Ashraf bin Zakaria and Abdul Aziz bin Marhakim. Our group project title is Nanofiltration. In the first process, we discuss about application of nanofiltration in many industry, and then we choose one industry that we want to do, which is landfill leachate treatment. After that, we separate the job so each one of us get their own part to do the slide for presentation. And in the last process, we record the voice for presentation. Lastly, I want to thank to Amirul and Aziz for doing their job